you're sorry.
I'm so sorry. It's literally a
Slap you right in
possible.
the face.
You've already quit. You've already quit.
I think you started my video with that. We're gonna have to check the.
Let's check the replay.
Yeah, we will. Okay.
You've already quit.
3-2. 3-2 is solving functions. We've got factoring, square roots, graphing, completing the square, quadratic formula. We have already gone over factoring, square roots, graphing, and completing the square. All we have left is the quadratic formula that we started and we did one problem with. And then we have the word problems. Alright, so let's get to. Well, please tell me I saved it.
I don't think you did. Yeah, you did.
We were past that.
I did not save it. I know we did.
We're on example 6.
Got a
No, wait.
white
Yeah,
boy on my
example
roster.
6.
PVP.
Okay. Brody, don't forget you're near the microphone.
Oh, yeah, he knows.
Okay.
Play the game.
We're on 6?
Yes.
Good.
We're on example 6.
Yes.
You're way past that.
Wait, yes, thank you. 5.
What you weren't doing on
Brody,
Saturday?
you are.
Here we go. Okay.
What is that?
Is this ready to begin the process of quadratic formula?
Yep.
Yes. What are we looking for to make sure it's ready? Do you remember?
If it equals 0.
If it equals 0, if everything's to one side. Because then we can come underneath and say, okay, this is A, this is B, and this is C. Did you like my technique with the crap?
Yeah.
Is it not bad? I mean, it kind of cleans up the
It's easier.
messy part. Alright, so let's find that crap, which is called the discriminant, by the way. There is a vocab word for it, and you do need to know this. It's part of your practice assignment, which means there is a chance it could be on the test. If the discriminant is one of 3 possible outcomes, it sets the tone for the rest of the problem if I was to finish solving it. Let's go ahead and solve it, and then I'll explain what this
Garrett,
means
get up.
down here. So we've got b squared minus 4ac. You type that in your calculator and you get what? -7. Now here's what I want you to do. Go to your calculator and type the square root of -7 and hit enter. You're going to get an error.
Because that's what you're talking about.
You should get -7. Confirm that. B squared minus 4ac. When you type the square root of -7 in your calculator, it should give you an error, right? When you enter the square root of -7 in your calculator, you are going to find that it gives you an error, which is why I like my crappy method better, because if you will find the crap separately from the radical, you will not get an error. You will get -7, and then we can now go and plug everything into the formula. And what is the square root of negative numbers? It's going to produce imaginary parts, imaginary solutions. So this means we're going to have to finish the problem by hand. Alright, so x equals -b plus or minus square root of that crap. Forgot the negative. All over 2 times a. You're going to like when the radicand is a negative number that is ugly like this, because there's less steps involved to finish the problem. It's kind of backwards, you know, like the ugly numbers end up being shorter problems. The pretty perfect squares end up taking longer because you have to break it down and then keep going. The only way to clean this up is to account, that's a 4, is to account for the I that would result coming out of that. which would leave it positive 7 over 2. Now remember we talked about in, I think it was Thursday, we talked about how on My Math Lab, they're going to want you to separate it and to put the I after the second fraction. So be ready for that.
It has to do that 3.92.
Huh?
It has to do that 3.92.
Did it? Okay.
How would you do
What? Restricted.
it? 5 over 2 plus or minus square root.
So in My Math Lab, it would look like this. Negative 5 over 2 plus or minus square root 7 over 2, and then the I after.
Is there a plus or minus on that?
No,
Yes.
is there?
Yes.
Oh,
Okay. I thought they wanted you to type them separately.
No, there's a plus or minus.
So it's in the
Shape
widget? It's in the widget.
Like when you remember you just type in everyone there, it's
It's in a box.
When in doubt, look at the widget. There you go. All right, so let's talk about this. This means a lot, and this should be short, sweet, and easily answered. Never get it wrong, but people tend to overlook it because it's so short and sweet. They forget about it, and then they just guess, and then they get it wrong. The discriminant is b squared minus 4ac, okay? That is called the discriminant. If you go and find the crap, and you come to a positive number, if you were to finish solving the problem, you would come to 2 real solutions because it came from a positive discriminant, right? If you go to find the crap and you come to a 0, what's the square root of 0? 0. So imagine putting it together in, let me show you this. Okay, we said if the crap is a positive number, then your x is going to come to 2 real solutions. If the crap is the number 0, think about it. You'd have x equals negative b plus or minus square root 0. What's the square root of 0? So this is negative b over 2a, because what happens when I add 0? What happens when I subtract 0? So this is a single one real solution. When the crap comes to a negative number, you would have 2 imaginary solutions because you can't take the square root of a negative number. All right, so wrap your mind around this right here. There's 3 scenarios. You either had a negative, that's definitely positive. You have a positive crap, you have a negative, or you have the actual number 0. And then imagine finishing the quadratic formula. If I take the square root of a positive number, I have 2 possible answers. If I take the square root of a negative number, I have 2 possible imaginary answers. If I take the square root of 0, then this goes away, and I have just a single real answer. Does that make sense? That's what this table is describing to you at the bottom of this slide. They did write it in a different order. I like to put 0 in the middle because obviously negative, 0, positive. But if you look at the bottom of the slide, they're saying if it's 0, if it's positive, if it's negative. Okay? That's part of the practice problems. I'm pretty sure you're going to have a couple of practice problems that say, find the discriminant of the following quadratic and determine how many and what type of solutions exist. That does not mean solve it. That means find the crap and then answer the question. You with me? So there's some ugly ones in there that you're not actually solving them. You're just doing b squared minus 4ac, and then you're looking at the sign of your answer for the crap. I don't know if you want to write that down or maybe go next to where it is on your your paper and elaborate next to it. Here, I can put some more stuff. So like this was one real number. So when it's equal to 0, it's 1 real. When it's positive number, it's 2 real. When it's a negative number, it's 2 imaginary. All right. Now let's look at the applications.
This looks like a lot of fun.
Okay, so you're looking at this slide right here. Look at the example. Stay with me. Everybody wake up. X to the 4th minus 5x squared plus 4 equals 0. What type of polynomial is that? What's the degree? 4. It's the degree to the 4th power, which means it's a quartic, right? What have we been solving in our notes? Quadratics, which are degree 2. I'm going to teach you how to take a degree 4 and reduce it to a degree 2 polynomial through what's called U substitution. U as in the letter U, not Y-O-U. We are going to take, if you look, here's an example. We're going to take and assign, no, can't read that. Hold on. We're going to assign x squared to the letter U. So then I'm going to take x to the 4th power and I'm going to rewrite it. I'm going to tweak it so that it looks like x squared squared. Because now I can go in and take the x squared out and I can put the letter U, bring down that squared. This was already x squared. I can change that to a U. Now I have a quadratic in U substitution form that I could solve like the normal way, and then I could go back and account for the additional solutions because it did come from a 4th degree polynomial, not a 2nd degree. So I'm going to show you how to do it. It's really not bad. It takes a little bit of practice. It's all about substitution. You do need to remember if a polynomial has degree 4, then that means it can have up to 4 solutions. So if I give you a degree 4 polynomial and you only have 2 solutions, there's actually 2 more that you've left out. So that would not be full credit. So make sure to keep that in mind. Degree 4, we'll get there in a minute. All right, so hold on, don't look at that one. All right, so let's say possibly 4 solutions. So keep that in mind right here. This degree 4 means possibly 4 solutions. Okay, here we go. So we're going to say, hey, I can't solve that. That's a quartic. I need it to be a quadratic. I'm going to let U equal x squared. I'm going to use the substitution method with the letter U. And everywhere there's an x squared, I'm going to put a U instead. Now right here at the very beginning, I don't have x squared. I have x to the 4th. If you need to, you can rewrite that as x squared squared minus 5, and then we already have x squared, plus 4 equals 0. Now, everywhere there's an x squared, I'm putting a what? A U. I'm going to change color so you can see it. Notice I no longer have an x in there at all. If you have an x, something's wrong. Don't let the U throw you off. Think of what we've already practiced. That is a quadratic with a leading coefficient of 1. The first thing we practiced was solving by factoring. Let's see if it'll factor. Multiply A times C. Product is 4. What are the factors of 4 that add to negative 5? Negative 4, negative 1. Because we learned the shortcut, I would encourage you to keep doing the shortcut because this is one of those lengthy problems. The shortcut was A and then the variable, A and then the variable, and then the two numbers you just came up with. You said negative 4 and negative 1. Y'all with me? Now the idea is solved, so we're not done. Those are just the factors. So those are being multiplied together to equal 0. So one or both of them has to be 0. So I'm going to pull the solution. What would come out of this? Not does it. Yeah, u equals 4. What about this one? 1. Y'all see how I got that? You would set them equal to 0 and you would solve. Did the problem start with you?
No.
No. Here's where some people are like, ugh. You've got to go back. When I say go back, I mean like now we have u by itself. Now go back to the x squared. U was x squared. So this is x squared equals 4. X squared equals 1. You can see where this is going. Square root both sides. Don't forget when you take the square root, you have two possible answers afterwards, right? That's where the 4 come from. So we have x equals plus or minus 2, x equals plus or minus 1. That is 4 answers. Right? Not bad. Don't look at the next example yet. Don't look at it.
Oh.
It's really not that bad.
Why is there
You see the
fractions?
fraction and you're going to be like, forget that one.
Why is 1 2/3 and 1 1/3? Why are they not the same?
Because the first term's supposed to be squared and the second term's not. Look right here at what I started with. This was to the 4th and this one was squared. So they're not supposed to match.
One's 2/3 and one's 1/3.
Right.
They're not the same.
Okay.
Okay, let me give you another nice one before we do the fraction one. So can you find like some blank spot? Maybe go to the very last page.
Oh,
Let's go to the last page.
Whoopsies.
We're going to solve x to the 4th minus 5x squared minus 36 equals 0. You're going to solve that by u substitution. This step right here is not necessarily required because if you already understand that 5x to the 4th, no, not 5x, sorry, x to the 4th is x squared squared, and it would become u squared, then you could skip that part if you wanted to. Oh, wait, let me use my colors. All right, so u. Okay, so let's see if it factors. Factors of negative 36 that add up to negative 5. Negative 9, 4. So the shortcut is AX, the number, AX the number, although a is 1, so don't write the 1, and then x is actually u. So what solution comes out of u minus 9? And what about this one? But u is x squared. You're going to square root both sides. Did you get those? All right, I'm going to show you the next one. Go back to that slide, and let's do 8. Also, if you would come right here and make a note that this is called U substitution. All right, so example 8. When you first look at it, obviously you see the fractions and the exponents. Notice this whole slide is the only ones that we've had where the exponents were not your typical, squared to the first power and then a constant. So that's your indication that this is the U substitution route. It's a different set of exponents. We've got 2/3, 1/3, and then nothing. By design, we need the first term to become squared and the second term to be to the first power. You're going to look at B for help. Look at B for help, because whatever the exponent is for the BX term has got to become a 1. Okay, so that's what immediately has to sub out. So if I see this, I see 2t to the 1/3 power. I need that to become just 2t to the first power. So what am I going to what's my exponent that I'm going to use? To the third, to the 1/3 power. Okay, let me change colors.
So that would be 3/1, which would make it.
Wait, don't make it 3/1.
Wait.
Oh, I see what you're saying. Well, hold on. All right, so come right here. I'm going to let u equal, now there's no x here, it's a t. I'm going to let u equal t to the 1/3 power. Right? Because I need it to become u to the first power. So look at t to the 2/3 power. If I rewrite that right here as t to the 1/3 power, what would I have to multiply it by to get t to the 2/3 power? 2. If you need a refresher on that, if you have, let me write it out like this. T to the 1/3, you see that? Times, or squared, squared. You multiply them straight across. So you would get t to the 2/3 power. Take that off. There we go. Okay. So I've rewritten that. I'm going to bring this down and just write it exactly how I see it. And then now I see t to the 1/3 right here. And I see it right here. And this square comes down, -2 minus 3 equals 0. Do you see how I did that?
Good job, baby.
Upward.
I lost you, didn't I? No? Okay.
What's that? Oh,
The
Yeah.
bar
No.
that you swing your foot on it comes loose.
Oh, so I didn't break it.
No, you
Notice
didn't
how
break
Parker's never done that in the one day he's been.
it. He always stands. He never sits.
No, I said
Parker stands the whole time.
sometimes I'm too tall.
Now we can finish this. Factors of -3 that add up to -2.
-3.
And a is 1, so I can go straight to this. Did you get that? solution comes from u minus 3. If I set that equal to 0 and solve, I get u equals 3 here,
Minus 1.
negative 1. Woo! So while it all started to look pretty there for a second, now you've got to go back to t to the third power. So this is actually t to the 1/3 power equals 3, and t to the 1/3 power equals negative 1. We need t to the 1/3 power to be just t to the 1 power, which means I need 1/3 to become 3/3, because 3/3 is 1. Y'all with me? Let me say it again. I have t to the 1/3. I need it to be just t to the 1 power, right? I'll write it right here. I need it to be t to the 1 power. Well, the only way to get 1/3 to become a 1 is if it is 3/3. You with me? What do I need to do to 1/3 to make it become 3/3? Multiply by 3. 3/1. So right here, let me show you. I'm going, oh Lord, I'm going to cube this, and this, and this, and this. Because if I cube it, I'm going to show my work. If I cube that, I would end up with t to the 3/3 power, which is the same thing as t to the 1st power, which is 27. Here I would end up with t to the 3/3 power equals negative 1, which is t to the 1st power is negative 1. I think you have one fraction problem in your homework.
So, do these only have 2 solutions?
Yes. Your extra solutions only appear after you square root. And we didn't have to square root. We went the other direction. We cubed. All right. Word problems. Everybody's favorite. Go to the next slide. We're talking about the museums in China. The number of museums in China increased from approximately 2,000 in the year 2000 to over 3,500 by the end of 2012. In 2012, a record 451 new museums opened. For comparison, in the U.S., only 20 to 40 new museums were opened per year from 2000 to 2008. The function h of x equals yada 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 can be used to estimate the number of museums in China x years after 2005. Here's our source. Is there anything in there we don't need? There's some stuff in there that is not necessary. Y'all stay with me. The source is not necessary. Yeah, if it'll, yeah. The source is not necessary. Always go to the function, box it in, because that's absolutely necessary. Find what the variables stand for, underline them. This function represents what? They tell us. What does it represent?
The number of museums in China.
There you go. It's the number of museums in China. And then what does x represent?
Years after 2005.
That is also important. X is the years after, and I'm going to write it right here so it's not randomly all the way over there. Years after 2005. So if X is 1, we're talking the year 2006. If X is 2, we're talking year 2007. Keep that in your mind. You might even want to make a note once you underline it, you know that note X equals years after 2005, so that you'll remember that. Now, they told us that the function represents the number of museums in China. They told us what X is. They gave us some type of record for how many opened in the U.S. Estimate the number of museums that will be in China in 2017 if the number of museums that open per year continues growing at the same rate. That really long sentence is simply giving you a question to say, evaluate X at this number and tell me what you get. They're saying, assume that the rate that it's opening stays the same. Otherwise, that makes sense. That's self-explanatory. Otherwise, your function wouldn't be useful if we couldn't go with it. You know what I mean? Remember when I told y'all with word problems, if there's two variables here. What's the first one? Number of museums, which is represented by what letter? Number of museums is represented by H. And then what's the other variable? X. There's two variables. If they ask for one, then they're giving you the other.
Sorry.
If they ask for one variable, then they're giving you the other variable. I'll figure it out. So it says, estimate the number of museums in China. That's secretly saying find what variable? H. Which means they're giving me X. So it says in 2017. 2017 is how many years after 2005? 12 years. So X equals what? 12. I'm going to put A right here. So we're finding H when X is 12. So H of 12. Go to your calculator. Type it in. And by the way, you are going to get a decimal. We're going to round to the nearest integer without going over. So type it in and tell me what you get.
You said nearest 10?
That's integer. Whole number.
Oh, 6807.
Yep. Did you get 6,807?
Yeah.
Approximately. We'll do squiggly marks because we rounded. All right, look at B. In what year was the number of museums in China 2,600? Read the question. Underline your clues. In what year? That means find what? X. Was the number of museums in China 2,600? That means H is 2,600. H of X is 2,600. So, find X when H of X equals 2,600. That's what we're doing here. And I'll run out of room. All right, so I'm going to replace H of X with 2,600. No, I'm not. I'm going to do this because I've run out of room. All right, 2,600 equals 30.992x squared plus 4.108x plus, this is giving me a headache, right? Well, we just had an entire section on solving quadratics. You think I want you to factor that?
No.
No. You think I want you to do quadratic formula?
No.
No. No, I'm not that mean. What technique of the ones we've learned would be the smartest and fastest when ugglers are my mouth spoke faster than my mind could think. I was thinking numbers are ugly. When the numbers are ugly, what technique is the safest way to go? Calculator. Graph it. Let's graph it, and let's let the calculator spit these ugly numbers out. Now, before you can type it in the calculator, though, you do need it equal to 0. Like, it's got to all be on one side. So we need to subtract this from itself, and then come over here to its like term that has no x. So when you go to the calculator, you're actually going to enter this beginning stuff, middle, and then right here you're going to have this. Right? So you will go to y equals, you will type this in. Yeah. Please tell me how it started. Recording. Yes. Go to y equals, type it in. Then we've got to find it. Because if you just do Zoom standard, odds are you're not going to see it. These are some really big numbers, right? Well, we're not asking a certain value. We're seeing where it crosses the x-axis. So we're going to have to go to the graph. So go to y equals, let me type it in, 30.992. Just watch. Sometimes this thing is... Alright, I'm going to do Zoom standard at first, just to see. Okay, can't see the whole picture, but I can see where it's crossing the x-axis. I see it's crossing in two places. It came from a quadratic. Guys, know enough to know what you're looking at. That's a quadratic. That means two possible chances to cross the x-axis. It's crossing in two places. I can see one here and here. Which one can I eliminate? Why? X represented years after 2007. You can't have negative years after 2007. So you disregard the one that is out of your domain for this problem, and you focus on just the one that could potentially be the answer. Looks like 3, but I would recommend using this second calc feature to get good practice for when it's not 3. Or not pretty, sorry. So second, not second alpha, second calc, find the 0. Remember, that's the intersection with the x-axis. Then I've got to find my cursor. Let's just start arrowing. Look where my cursor is. It's at 1, -266. If I hit my arrow, I'm watching that number get closer to 0. So I'm just going to keep hitting it. There it is. See that?
What do we round it to?
I went to whole number. I rounded to the nearest whole number.
Right.
So there's a left bound, there's a right bound, and there's a guess. 3.07. So x is approximately 3.07. Now in terms of years, we're going to say 3 years after 2005, which means the answer is 2008. Remember in word problems, when you have variables, they're going to give you all but one variable and ask you to solve for it. So we just did a whole section on solving quadratics. Let's go to the next one. This one's short and sweet. Magazine closures. The numbers of both magazine launches and magazine closures have increased in recent years. Here's a function to represent that. It can be used to estimate the number of magazine closures after 2012. Here's our source. In what year was the number of magazine closures 99?
This sounds like a lot of excess
Well,
words.
first of all, I'm going to box this in because that's my function. I'm going to mark out who told me these numbers because I don't care. Right? I don't care about the source. I believe you. Then I'm going to make note of what my letters mean. The function m of x can be used to estimate the number of magazine closures. This function represents the number of magazine closures. X represents what? Years after 2012. In what year was the number of magazine closures 99? In what year means find X, which means they're giving me M of X.
Is X years after 2012?
M of X is the function to estimate the number of magazine closures. Remember, your input is always, what is it? Yeah, but I was going to say your input's always time. Because when you're looking at a graph, your x-axis is always time, because time is consistent. What changes is the y-axis. So always think of that. Okay, so m of x is 99. 34x squared minus 59x plus 81. I'm going to subtract the 99 over to its like term. And then I get a quadratic. We got 34, 59, and 18. Those numbers are really big. It does not look factorable because I'm not familiar with 59 having any, 59 product multiplied of product of 34 and 18 that adds to 59. So I would go to your graphing calculator and type it in y equals. What do we have? 34x squared. Jeez. Squared. Minus 59x minus 18. Zoom 6. Which one can I throw out? I can throw this one out, and I'm going to check this one. Looks like 2. Let's check it. Second calc. 0. Find your cursor. Right now my cursor's at 0, negative 18, so it's sitting down here on the y-axis, so I'm going to go to the right with it. I can see it's climbing further down. Oh, now it's going closer. There it is. You need a left bound, a right bound, and a guess. There's my left bound because it's coming from up underneath it just a little bit left. So hit enter, go past it, there's your right bound, then come back to it. It is not, now this is what drives me nuts with the calculator, it is not even remotely close to the guess, and it will not physically let me get remotely close to it except for that one right there. But you need to know that it's okay as long as you put your points in the right spot in terms of left, right, close, close. It'll give you the right answer. So 2. So we found X to be 2 years after 2012, which means the answer is 2014. What?
Shut up. Pythagorean theorem.
Yeah, old Pythagoras. I saved the best for last.
Yeah.
Old Pythagoras. Oh,
She'll see it.
go to this.
Those friends.
Probably shouldn't have made the picture so big, but all right. 2 trains leave the station at the same time. Nobody cares. One train travels due west, and the other train travels due south. The train traveling west travels 20 kilometers an hour faster than the one going south. After 2 hours, the trains are 200 kilometers apart. Find the speed of each train. You do have to recall the motion formula.
Huh?
D equals RT. You don't really have to recall that necessarily, but you end up using it anyways because we're talking about speed, right? D equals RT. How much time has passed, by the way? 2 hours. We've got a southbound train and a westbound train. Let's read it again. One train travels west, the other south. The one going west is going 20 kilometers faster, right? Okay, so I'm going to make a note that the westbound train is going at some speed that we don't know, right? But with a 20 kilometer per hour faster rate than the one going south. So if it said the trains are going the same speed, we would call both of these R. But the fact that it says the westbound train is going 20 kilometers faster, we've got to take that into account and say plus 20 right here. Do you see that? All right, let's go to our picture. How much time did we say? I forgot to write it. We said that 2 hours has passed. We have a westbound and a southbound. Please don't mess this picture up. South is down, west is left. Okay, so right here, we are going westbound at that speed we said, R plus 20, and we have traveled for how long? 2 hours. So because this is a binomial, I'm going to put it in parentheses and multiply it by the 2 hours. Now that's unsightly. So what could I do to clean that up? I could distribute and say this is, I could put equals or I could put or, but this is actually 2R plus 40, right? Now the southbound train is not complicated. It's going at a speed of R. It's traveled for 2 hours. How far apart are they? 200 kilometers apart. Who's the good old guy that came up with this? Pythagoras.
Pythag.
The Pythagoras theorem, Pythagorean theorem. A squared plus B squared equals C squared, where C is the hypotenuse. This is your C. The other two don't matter, right? Now you do have a binomial that's fixing to get squared, so be careful. So let's plug it in. we've got 2r plus 40 squared plus 2r squared equals 200 squared. Please don't write 4r squared plus 1600 at the beginning. What do you have to do there? You've got to multiply it out, first, outer, inner, last. If you need to expand it, 2r plus 40, 2r plus 40. Now this we can do, this is 4r squared, right? We multiply 2r plus 40 out.
Whoa.
Right? I put 1600. Yeah. Combining like terms, I've got, let me color coordinate. I've got 4r squared, 4r squared. I've got 80r, 80r. And then
Why are they
plus
yelling?
1600 equals 40,000.
They're being loud. This Holcombe must think you need to go tap on their door and tell them to quiet down.
No, I handle my business in private. All right, I'm going to subtract the 40,000 over because I have a quadratic here and everything's looking really good. What do you notice about every single number? They're definitely divisible by 2, potentially divisible by 4. I'm fixing to subtract. We need to convert.
I think they're all divisible by 8.
We'll check it. I'm going to subtract 40,000 up underneath this. What do you get? Minus 4,800 equals 0.
Where'd you get 4,800 from?
I subtracted 40,000 underneath, so 1,600 minus 40,000.
That's not 48.
It's negative 38,400.
Oh, I already divided. Thank you. 30. It's 38.
4.
Sorry. I'm just excited because I'm fixing to make the problem so much prettier. How? You already said it a second ago.
Divide.
By
8.
every single term in here. Look at this. This, and this, and of course 0. Every single one of those terms is divisible by 8. So I'm going to draw a line and say divide by 8 under the whole problem. Every single term.
That's Mr. Warren. Better read him.
What?
It was the other way.
The other which with a B instead of a W.
Bye-bye. Now, don't quit on me. I don't want you to quit.
Female dog.
Okay, no, don't quit.
I'm not
Here's what I
quitting.
need you to think smarter, not harder. We're college
I'm
level.
not a quitter.
Listen, I'm going to talk over it.
If we're late to
See
class,
20 and 4,800. I want you to look at it and only see 2 and 48. What multiplies to give me 48 but adds to give me 2?
86.
6 and 8. So what multiplies to give me 4,800 but adds to give me 20? 80 and 60. You see where this is going?
oh, so it's just
So
R.
it factors into
80 and negative 60.
positive 80 and negative 60. Yeah.
So R plus 80, R minus 60.
Now remember those word problems that we graphed it and we always had one that got thrown out?
Negative 80 is
The negative 80 right here gets thrown out because that's not possible. 60 is your answer that you can stay with, go back to what you assigned your variables as. So 60 is the southbound train speed, which means the westbound train is going 80. And that always works out like that. The one you end up throwing out ends up being what you get after you put it in. South is 60 because I got R right here. Yeah.
And keep.
And west would be 60 plus 20, so it'd be going 80 kilometers.
Divided by 8 and factor it.
Ready, bud?
Yeah, almost ready.
Rock me, mama, like the wind and the rain. Rock me, mama,
Factor
like
it and
the
then
sound.
plug it in. And you throw out